Good morning, everyone, and welcome to our first BioDT webinar. My name is Rita Giuffrida. I am a researcher at Trust IT Services, and I am also one of the BioDT partners, and in particular, I am involved in dissemination and communication activities. I'm very pleased today to join you to this webinar, and as you know, this webinar is a little bit technical, as in the next hour, you will have the opportunity to understand a little bit more how the Biodiversity Digital Twin prototype is going to be developed. So just before starting our webinar, I will just show you the agenda. So as you will see, it will be an hour event. You will just have a 5 minutes introduction from me and get a little bit of practical information about this event. After that, I will pass the floor to Tomas Martinovic from IT4I, that instead will start to introduce and present to you the digital twin platform prototype. After that, I will pass the floor to Sergei Zaiaev from the University of Tartu, that instead will better explain how BioDT is going also to exploit the potential of the high-performance computing and LUMI supercomputing to build it. And our last speaker is John Watkins from the UK Centre for Ecology and Hydrology, that instead will explain a little bit better what is the role of the research infrastructure to build BioDT. Feel free to ask any questions to our speakers in the related Q&A section, as later on, after all these presentations, you will also have the opportunity to address your questions and learn a little bit more about all these presentations. Just a quick information to all of you, as today we're really expecting to have a lot of people, actually from a lot of different countries. We're welcoming today research infrastructures, people that work in research infrastructures, research institutions, industry, and also some policymakers. And we're very pleased to see that people are really joining from more than 20 countries worldwide. As I have already said at the very beginning, this is not our first webinar. This is our fourth, as BioDT already started this journey a year ago. So if you would like to hear and learn something more about BioDT, we also invite you to watch our recordings of our three first webinars. They were more focused about the general objectives of BioDT, about the use cases that the project is going to develop, and our cooperation with Destination Earth. So, and do not forget also to follow us on our social media channel. With this, I will welcome all of you again to this webinar, and I'm passing the floor to Tomas. Thank you.
So, hello, everyone. I just share my screen. So can you see my screen? Fine, right? So I'm Tomas Martinovic from IT4Innovations, this institute at VSB Technical University of Ostrava. I'm a senior researcher who is leading a team that is focused on mainly machine learning, advanced statistics, and AI. But in terms of BioDT, I am leading a work package concerned with user requirements trainings, and also I'm part of the work package concerned with the technical infrastructure. So today I will present to you the technical design of the technical infrastructure for the BioDT. Its prototype. So I will first start with our definition of the digital twin, because I think everybody will ask these questions. What's the digital twin in the context of BioDT? And what we how we define the digital twin is that it's typically composed of data, a model, and an application that connects those data and models in a way that makes outputs of a model relevant given to the specific purpose of the digital twin. So what we can imagine is like in industrial digital twins, usually you have some products, designs, operations, and you have a lot of sensors on those industrial parts, and you are making some continuous survey. In the biodiversity, most of you probably know that is not so easy. You most of the time do not continually just see everything in real time. There are some applications like that, not all of them. And actually, our platforms will support multiple digital twins, and we will have like multiple digital twins outputs, and they will be based on different models on different things. And that means that also the definition of the digital twin needs to be also a little bit adjusted. So we say that in BioDT, the digital twin mimics the behavior observed in nature, meet the requirements of the BioDT use case, and also contribute towards the European Commission goal of devising a full digital twin of the Earth. So that's some kind of long-term perspective. Now, when we start in the platform, we require some kind of computational simulation, and like BioDT supports, this whole thing we can see here, like from the laptops, clouds, and servers. And BioDT is very focused on the HPC and LUMI, but actually all of the results should be able to run on different platforms, so also different HPC side, different cloud environments. But for now, we are focusing on LUMI. And also we expect that the services that will be provided by the BioDT should at some point become part of the EOS core services catalog. And when we look at these also, it means that, for example, users can use their laptops to interact with the digital twins, but quite often it happens that the computation will happen actually on LUMI and at the HPC or some cloud services, depending on how computational extensive those computation or those digital twins are. And when we were designing the whole thing, we had to take into consideration many different things. Like I guess most of you are not really know how the HPC works, and the HPC works in a little bit different way than the cloud services. So some of you might know how it works with clouds. You create an account, you log in there, most of the time you pay some money and you can run some Dockers or virtual machines in the cloud on some architecture. With the high performance computing and high performance clusters, this is much more difficult. You usually need to have some kind of computational projects. You need to ask for that project. That's service. You need to really write several pages describing what you want to do, and then you get some amount of money usually for the research. If you have some kind of private high performance computing center, then of course this can be a little bit different process. But LUMI will be mostly like public and for the research oriented, and there's this complicated process. So what we wanted to do is that we wanted to ease this process as much as possible. Also, then usually if you do not have the graphical user interface, you can have some ways how to get to it, but still you need to do like SSH to the HPC, and there are many very specific steps that are oriented on the Linux. Not everybody is used to that, and sometimes you just want to have something at the HPC, and then you want people to interact with it without knowing that it runs on the HPC, and that is pretty much what we see in the BioDT. Most of the users do not really care whether it runs on LUMI or where the execution happens. They want to just be able to leverage these digital twins. And this is one of the most important facts when we were considering the tools for the architecture. And what we came up with was something like this. So I think this slide looks a little bit overwhelming at first, but I try to make it simple and try to show it too. So first thing, one important component that we have is Puhuri, and that is used mostly for the authentication authorization. So users should have this one Puhuri account when using the digital twins. And they use that one for executing on the computations. Also, for the people who are actually asking for the resources, there is resource management options in Puhuri, and it can simplify for them the whole process of how to get the resources. And I think there will be a little bit more in the second presentation now, also about the Puhuri. And then the second very important part of the solution is Lexis platform. And Lexis platform is actually used to this high-level workflow execution, and is used to pretty much hide these complicated HPC stuff from the people. And how does it do that? Is that it uses this tool called HPC as a service middleware called HIPI, and that one can create like robot accounts of the HPC, and it can kind of take care of what people are running on the HPC, and then put it into the Lexis, and in the Lexis, and with Lexis, user can actually work just through the web interface or some API that that means that they really do not need to see that HPC stuff. One prerequisite for all of this to work is that there still need to be somebody who will deploy the code on the HPC, and that's pretty much taken care by the BioDT team in this case. So the user will not need to really somehow worry about that. And what we imagine is that we will create some GUIs that will use the Lexis APIs. So they have this specialized interface that should be even simpler than the Lexis portal, and just has really just the components that are really needed for users to interact with the BioDT. So this is some kind of general overview, and now I try to be a little bit more concrete, I guess. So when we are looking at this diagram, this part is mostly the Lexis. This one with the, I don't know what it is, light brown, beige color. On the bottom is the BioDT infrastructure layer, and there's one where these all the like mostly hardware and software are, or like the infrastructure, so the HPC and the cloud. We can see that the HPC can be LUMI. There will be like LUMI G, LUMI C, Carolina from the I4I. There might be also other HPC sites added later on, and there should be also some cloud available at IT4I or at CSC. And important thing now is probably there's one more question is about the data. So there are two ways how the data will get to the infrastructure. One is that you can now directly store it at the HPC center, and it will be stored like in the Lexis distributed data infrastructure, or the data could be stored at, for example, JBeef Altair, or it will be taken from the destination Earth digital twin, this FDB. And through the APIs, the data will go directly from these research infrastructures. So in the BioDT, what we foresee is that at least some of the use cases should be prepared in a way where user will have a parameter. Okay, I want to use these data sets for my exploration from the JBeef. I'm not sure yet how exactly it will be done. whether it will be DOI or something else. That is something that modelers will probably specify when they will be finishing these models, but you should be able to set up, okay, I want to use these data sets or these data sets for my digital twin, or you might have the option, okay, I want to upload some of my data, and you would be able to upload your data directly to the HPC infrastructure, or you can upload your data to the research infrastructure and take it from there. So there will be mostly these two ways how to do that. If you, for example, need some kind of data that needs a private connection, then there is also vault for external credentials for some kind of private data that are not publicly available. One more thing that I haven't mentioned now is also the BioDT digital application repository. And we will have these application repositories where you will see like workflow registries. If there will be some containers, they will be probably a Docker hub. So they should be public. We will have a GitHub repositories with code for the digital twins. And we have maybe we will have also some specific repositories like private GitLabs or something like that, where a private code will be available to just specific users. So this is pretty much this solution that we came up with. And now I will get a little bit also to the user interaction a little bit more. So the execution of this digital twin then can be done through the Lexis API. We foresee that there will be Python SDKs or Python library, our library to use the BioDT. There will be special GUI prepared. We foresee that will be most likely our Shiny application. And there is also a Lexis portal that could be used for some more technical people. So the execution of the digital twin and also the data handling can be done through these APIs. Probably specialized GUI will not have all of those features, but in the Python and R libraries or the Lexis portal, I foresee you should have most of the features that Lexis provide. And I already mentioned the data handling that you can use either the research infrastructures or the Lexis distributed data infrastructure for the private or special cases. And one last thing that I wanted to say was this BioDT technical platform. So we have already some questions about people, okay, how can we be part of the BioDT? We have this really nice use case, we would like to be part of it. And this is pretty important also when we were choosing these technical, these tools, was that, for example, thanks to the Lexis platform, there is no need to depend on Lexis during the development of the use case itself. Important is that you are able to get that use case on the HPC. And as I said, this HPC is pretty specific. So you need to be able to deploy it on the Linux cluster. And when you have this bash script that could look something like this one on the right, and it will have some parameters defined like this, then pretty much is already able to become part of the Lexis. And if you have something like this prepared, then you can just say to the BioDT guys, okay, we have something like this, can you just take a look at it, and could this become part of the BioDT? And we then would take a look at it, somehow do the review and so on. And then it could be up and running in matter of hours or pretty much. So that is, I think, very nice thing. And also for the cloud parts, the Docker containers are supported directly. As I said, data transfers are taken care by API. And there's this Lexis high-level workflow that is provided by Apache Airflow, but you do not need to depend on the Apache Airflow. You actually can have whatever you want in that HPC script or in your Docker if you want. And or you can have these like low-level orchestration, workflow orchestration frameworks that you want, you can use inside of your task. So like this Lexis workflow is really just at high level and doesn't restrict you in any way. And that is pretty much all I wanted to say. So thank you very much.
Thanks a lot, Thomas, for this very complete overview, I have to say. And now instead I will pass the floor to Sergei, that instead will provide a little bit more details on how BioDT is also going to exploit the potentials of high performance computing resources, and in particular the LUMI supercomputer. So Sergei, I will pass the floor to you now, and you can also share your screen. Thank you.
Hello, my name is Sergei. Let me show my screen. Okay. So my name is Sergei. I am a DevOps from University of Tartu. I participate in different projects related to LUMI supercomputer. One of them is the BioDT. And I take part in work package number 3 and number 7. The slides I will show you today are prepared together with my colleague Ilya Livingston, and let's start. Today I will describe the role of HPC and LUMI supercomputer in the BioDT project. So first of all, as you know, this is the diagram of the BioDT components, technical BioDT components, and today I will primarily focus on these two particular ones. So the LUMI supercomputer is a part of infrastructural layer that provides resources for BioDT services. BioDT services, as Thomas already mentioned, provides workflows, orchestration, while infrastructure provides resources for this. So in order to access Puhuri, in order to access LUMI, the Puhuri project has been created. Essentially, Puhuri is a web interface for LUMI supercomputer that allows a particular resource allocator to allocate some resources for particular users. So simply, this is the web application that provides interface for BioDT infrastructure layer. The allocation model of Puhuri consists of these steps shown on the diagram, and there are 4 main actors in this flow. The first one is a service provider. This is the organization who has resources and can provide them for external users. Resource allocator is an organization who needs resources in order to run workflows or create digital twins. Service is a resource itself, but not allocated yet, like LUMI supercomputer or Carolina. And the resource is an allocation which can be used for workflow orchestration by final users. Like as you can see, a project principal investigator can create an order that should be approved firstly by a resource allocator, then by service provider, and then provisioning should take part. That means that a system administrator from LUMI supercomputer, for instance, should create an allocation and report back to the Puhuri interface that the allocation has been created, and then order is marked as done. So this is the pretty straightforward flow. Regarding integration with HIPI, HIPI is a middleware that provides access to the supercomputing infrastructure. Lexis uses HIPI, and in order to integrate Puhuri with Lexis, we use two agents from Puhuri side. The first one is Robot Account Manager. It's not implemented yet, but it's planned to be implemented. So first of all, Robot Account is an association between set of users and a particular resource they can access. This manager works in two directions. First direction is includes generation of SSH keys and the registration of robot accounts in Puhuri core. And second direction includes injection of these generated keys to the HIPI. The second agent Puhuri rely on is the Slurm agent. This is the application that creates allocations and associations in Slurm cluster directly, and then reports the usage and accounting data to the Puhuri. And so we can in future implement the dynamic resource allocation for digital twins. The current model is a bit slow and not really flexible. Existing model assumes that allocation is already exists in the cluster, so it's pre-approved and pre-created, I mean. And in order to access it, a user has to register in my access ID and get access it from Puhuri core. The roadmap includes the support for dynamic resource allocation based on estimations of needs for a specific digital twin. That means that Lexis will play the role of Puhuri resource allocator, and dynamic creation of robot accounts with actor I have already mentioned in the previous slide will be implemented. So that's pretty much it. Yes, and I will be happy to answer your questions.
Thank you, Sergei. I will pass now instead the floor to John, who will instead provide a little bit more practical, let's say, presentation on that is a little bit more focused on research infrastructures and how they, let's say, cooperate with BioDT. And as also Sergei said, obviously feel free to ask us any questions, because then there will be a dedicated session where we can address all your let's say, questions or doubts about this. Thank you.
Okay, good morning. I'm John Watkins from the UK Centre of Ecology and Hydrology, based in Lancaster in the UK. I work on BioDT, on work packages associated with delivery of data services from the different research infrastructures, on the FAIR principles that we're implementing various services for. And also I work with ELTA as a research infrastructure to ensure the provision of data, but also the impact of the BioDT development to provide benefit to the ELTA community. So in my presentation, it's going to be a little bit different. It's going to be very much focused on how the digital twin development is seen from the perspective of providing impact to the user community from the research infrastructures that are involved. So first of all, this may be a bit of revision on the structure of the BioDT project. So as we've said, it's looking to address some of the EU initiatives around Destination Earth. It's the EU Digital Strategy, the Green Deal. We have structured what we want to do in terms of our impact into these 4 use cases. And within each one of these areas, 4 use case groups, there are individual use cases, and these are the things that I want to focus on today. We've also heard from the previous 2 presentations about services and platforms, and then we have the issues around who are the target groups, and it's very much the provision and the use of these services from these 4 biodiversity research infrastructures, GBIF, ELTA, DISCO, and LifeWatch. Quick revision on what digital twinning is all about. So as we've said, there is a real system out there somewhere. In this case, we're looking at biodiversity systems, how we want to represent those and how we want to improve the accuracy of how we can view different phenomena that are going on within changes in biodiversity, but then also how we can feed back into the management of those and also the accuracy of the representation. So that's really what we're trying to do within this concept of digital twinning. As we said, there are 8 use cases which we are using to trial this. And the idea is that these use cases bring together the resources of the different research infrastructures, but also give a broad user community for how the development of the digital twin can impact on the users of these research infrastructures. So that's what I want to go through today. I'm going to go through some very specific areas that relate to how we think this development can provide impact. So within the groups of use cases, I want to focus in on biodiversity dynamics. There are 4 particular developments in this area. There's one around grassland biodiversity dynamics, which we're looking at modeling climate scenarios and their impacts on the succession and development of biodiversity in grasslands. There's another one, which is a similar one on modeling of scenarios of climate change around forestry and bird biodiversity and dynamics. But the ones I really want to look at are the citizen science focused ones, which are around how citizen observers can interact with the digital twin around things like bird monitoring, and also around the cultural services from ecosystems and how that can be modeled and interact with the digital twin. So monitoring of the physical twin, if you like, is becoming very diverse. We have very diverse data sources, and what we want to do is to combine those and bring those into the potential we have for actually producing this virtual twin, and then enabling people to make decisions based on that virtual twin and feedback into how we might do the monitoring. So this is one of the key areas. There's existing data that we have, but there's a vast potential to bring in new data, not only through the actual research infrastructures, but also through many mobile devices that are now out there producing data on the state of biodiversity. So the first example I'm going to look at is the recording of migratory birds. So migration of birds and arrival of birds is a particular event, a conspicuous event within Europe, especially in the springtime. It's quite a cultural thing as well, in terms of the time at which particular birds may arrive is of great cultural significance in terms of, our perception of the arrival of spring or summer. But this is obviously clearly very sensitive to climate change, and there's noticeable shifts in some of these patterns. And this is something that citizen scientists are engaged in and can be engaged in terms of recording these shifts, and also feeding into predictive maps of how we might better understand what is going on. So data collected from citizen scientists can be fed into applications and modeling that can produce these predictive maps. This is not only enables us to understand better, but it also improves our science, because we can then use those data to look at how good our models are. So within the Biodiversity Digital Twin project, we are setting up a workflow that enables us to start to use these data and also train the models, and then feed that back into the concept of a citizen science based monitoring system. So one of the things is that we would obviously produce things like web portals for showing data and the predictions with a minimal delay. It says here real time, but I think this is one of the things we need to explore in BioDT as to how the infrastructure that we've been shown in the previous presentations can lend itself to real time or near real time applications in this sense. This can be conducted within Finland. There's an existing network that we can start to use to start to trial some of this. And this is one of the key use cases by which we can engage a large number of, well, in this case, bird enthusiasts, to start to see how these representations of bird migration and the arrival of bird migration, to engage them in recording, and then also in how those data can be fed back into our understanding and our reaction to how we might mitigate some of the impacts of these changes. The basic model is that we want to get applications onto mobile phones to enable people to record things such as the audio of birdsong. But in order to process that, we need to do things like train neural net deep learning type models, which is where we're looking to HPC type capabilities. We also have existing bird distribution models, which are fed from some of the data from the RIs for the long-term distribution of data migration, so that we have some sort of predictive capability. The observational data to come in to enable us to update those predictions, and then those are fed back to the mobile applications, so that the citizen scientists or the resource managers can actually interact with those in real time. So this is the sort of feedbacks that we want to be able to produce in order to really make the digital twin work as an interactive digital twin. So I'll move on to cultural services. So the previous example is a very clear example of where you're looking at biodiversity and the impacts of climate change, and how citizen scientists can interact with that, and how we can use the HPC to train up some of the capability. But what about cultural ecosystem services? So I've already mentioned that things like the arrival of particular species is of cultural significance, but really cultural ecosystem services can be really very simple. So we have a physical environment. People perceive that physical environment. They want to go to places where they get a particular sense of well-being within that, and that equals the delivery of a cultural ecosystem services. So this is not a very complex concept. It's something that we probably, a lot of us, do all the time. And the question is, well, how would the BioDT digital twin actually improve our ability to do some of this? So biodiversity, again, is recognized as a key ecosystem service around this, especially people wanting to use particular areas of the country to interact with biodiversity ecosystem services. If we think about, we've already talked about birds, but there's also things like flowering meadows. There's things like other animals that people might want to observe. And then there's the management issues around, well, for resource managers, how do they understand the way that people may gain services from their particular area, how they might improve that, how they might mitigate the impact of that. And then also, if people are using particular areas for cultural ecosystem services, how do we get information back from them? So there are recreational models. We have one for the Cairngorm National Park in Scotland. And what we're looking to do is to improve that by linking it better into models of biodiversity, to do some predictive capability around what might be expected in terms of interaction with biodiversity in those areas, but also to enable citizen scientists to improve our prediction of biodiversity through improving the data we have for that. So there are two things here. There's a recreational potential model. So this is how people may want to take advantage of the ecosystem services within the national park. So we have two models here. One is what we call soft recreationalists. So this is people who want to engage in low intensity activities, low level walks, short walks, versus people who may want to go to, on longer, more demanding walks or more than that in other areas of the national park. And what we do is we assess the environmental characteristics of the area. We do research with people in terms of how these may be used by recreationalists, and then we use that as a model to predict how people may use this and how land managers might improve management of the national park in order to provide these services. We're linking in the concept of that's been previously worked up in the DECIDE tool as to predictions of what biodiversity may be in that area. So if you want to know where you may interact with particular species, the DECIDE tool could do this in terms of a predictive capability, and this is data that's coming in from places like GBIF and some within Cairngorm National Park. It's from some of the measurements we take from ELTA. DECIDE also provides information about the level of uncertainty of some of those predictions. So one of the things it does is just to suggest where you may want to go and record biodiversity to improve the predictive accuracy of that model. So this is what we want to bring together in this use case. This again is enabling us to use BioDT to improve our modeling, and also to train some of the data that might be recorded by people interacting with these ecosystem services. So in that regard, increasingly people are in the environment not only recording images, but they're also recording quite complex soundscapes. So this image represents a soundscape over time and over the year, looking at the different types of audio information about a particular area, the types of things that are in that area, the types of things that are going on. We can identify individual species from that, but we can also identify things that are going on in terms of the use of those data by recreationalists. Also, background noises, the quality of the ecosystem service for recreation, such as particular audio soundscapes that people might want to go to. So the waterfalls or the wind in the trees, those kinds of things which we can actually pick up from these recordings. But it does mean that we need to be able to develop the models to actually interpret some of these, and that could generate a lot of data and would need a lot of processing in terms of training some of these models. So some of the neural net models that we'll be looking at are certainly things that we're now looking to stage onto the HPC, and then to be able to feed those back into some of the recreation potential or the biodiversity interaction tools such as DECIDE that enable people to not only record particular information about that, but also for the resource managers in, say, the national park to improve management of resources, but also measure the impact of particular activities that are going on. So again, we would expect some sort of mobile app and other applications that would be enabling different stakeholders to interact with this. So recreational systems, we talked about the recreational potential map, how they can use that to plan their interactions, but also feed back into the system. Wildlife enthusiasts, the probability of viewing particular species and how they can improve the quality of that prediction. The citizen scientists looking to actually engage in recording activities and improve this this provision of data through things like Decide. And then we have the scientists who are improving predictive modeling, also looking at the development of these machine learning algorithms that can interpret things like soundscapes, either to pick out individual species or to evaluate what the state of the environment is for providing recreational services. We have land managers who can interact with the data to see what the impact is, but also how they can improve interaction, and policymakers in terms of looking at the types of policies in terms of land access that may improve the system's interaction. There's a big feedback cycle here as well. Again, we are developing a framework, workflow as to how this could be staged. There are particular data streams, as we've said, coming from places like GBIF for the distribution of biodiversity, but also external data such as either the citizens or fixed acoustic or camera traps in places like the ELTA site in the national park. So there are a wide range of different data sources that are coming in. These are going into things like the recreational potential model, the biodiversity distribution model, which is similar to that would be being used for the bird song data that we've described previously, and then the probability of a measurement of the distribution of biodiversity for the Decide model. And these will feed back again into the user interface, which would be a mobile app, but also into the management interface to enable people, land managers, to interact with this. So we need to move through this workflow to see how elements of this can be staged onto the high performance computing platforms. This is a more detailed view of that. All of the different use cases that I've talked about are all developing these sort of wireframe diagrams to identify the individual models and how they interact and how they might be linked to users through particular applications such as the mobile apps that I've described, where they would be staged. So this is a key element of BioDT now, to say, okay, so we have existing models, we have existing data, we have a workflow as to how we want to develop these applications, but how do we actually make the HPC platforms work for us in terms of actually delivering these capabilities. So through this presentation, I think I've hopefully shown some of the ways in which BioDT can provide development of biodiversity research, and especially I've talked about ecosystem scientists and how they can interact with it. I think that's critical to maintain things like wider commitment to protection of biodiversity and safeguarding societal resistance. So I think over the last 3 years, I think generally people have started to value recreational ecosystem services far more and care about their management and welcome the opportunity to interact with them in the ways that I've described. And then BioDT will enable us to look at those trends, hopefully from those data in spatial terms and also in climate impact, and improve how we manage those resources and improve our predictive capability through things like biodiversity modeling. Thank you.
Thanks a lot, John, also for your presentation and also for providing a little bit more concrete examples of how we are also interacting with the research infrastructures. I see that, by the way, also some people were asking some questions related to your presentation, so then we can also address them in a couple of minutes in our dedicated Q&A session. Before moving to that one, I would like actually ask to all our attendees also to join a very small, let's say, little quiz. It will be done on Mentimeter. And what I will ask you to do is to go on a website that is called menti.com. I'm pasting here in our chat also the website. And what you have to do is to press the number 17272382. And after you do so, you should be able to see the screen that I'm sharing right now. So we will start this by asking you, let's say, a general question about how familiar you are with the concept of biodiversity digital twin. Obviously, the presentation that our speakers today have presented to you are related to the biodiversity digital twin prototype. So what BioDT is developing is not the final digital twin, but this is actually a prototype, a first phase. But anyway, we're curious to know if you have already heard about this, or if it was really your first time to hear about it. So hopefully you got also the opportunity to learn something more about our project today. And I see that more or less half you had, I mean, average understanding of the digital twin. As I was also sharing before, we have also organized our other webinars that were a little bit more general. So if you would like also to understand a little bit better what is the general, what are the general objectives of this project, I really invite you also to rewatch all our webinars that are also published on our YouTube channel. So thank you. I will now move to the next question. There instead is an open question, so you can type what are your considerations, let's say, about the biggest challenge that, in your opinion, our team or any other developers can expect when they have to predict global biodiversity dynamics. This is a little bit more technical question, but if you have any ideas on this, we will be happy to hear them. So, okay, the first one is related to the lack of enough data, which is a common problem actually when we are dealing with the development of data structures. Then we also have other topics about the complexity of the measurement, data integration, model complexity, scalability. Okay, so then I see that in the majority of cases, it is really about the fact that we do not have a lot of data to really make reliable models, also prediction models for this. Maybe we can also take some of these inputs, and then also I will ask also our speakers, so Tomas, Sergei, and John, also to elaborate a little bit more about these inputs in particular during our Q&A session. And thanks already for sharing this. And now I will ask you the last question. That is again an open one. This one is about the benefits. So in your opinion, what are the benefits that you can see by using the high performance computing, or for example also the LUMI one that was also presented by Sergei today, for developing the biodiversity digital twin prototype? Again, here you can type in your perspectives, and then again we can also take this question and elaborate it a little bit more during the Q&A. Okay, so I see that some people are already replying, which is very nice. So okay, the first one is about that in this way we can also have an improved monitoring and decision making. So yeah, for sure, I mean, this will help with the overall development of the infrastructure, also by the faster calculations. Okay, and also another comment about this is also that we can have real-time calculation and yeah, but a better analysis of the data overall, quicker feedback that we can get, also, let's say, higher, let's say, better, let's say, improvement of calculation in general. And I see again that there is another comment about the speed of calculation. So yeah, I see that more or less the inputs that you're providing are more or less all oriented towards the speed of calculation of performances, and also by the better resolution that this infrastructure can have. Sorry, the interaction with the HPC can generate. So I thank you all for taking part in this very little quiz, and we will now start from all these inputs also to address them and expand them a little bit in the Q&A session. So maybe I see that some of the people here have also asked some of the questions in the Q&A chat. So maybe I will start from these questions, and then I will actually ask also everyone to expand a little bit on the comments, let's say, that we have received on the Mentimeter. So the questions actually, John, are all for you. The first one is for Tony, from Tony. Thank you for asking this question to us. And in particular, he would like to understand if the UK Centre for Ecology and Hydrology and BioDT have been, let's say, have used the biodiversity net positive and neutrality cases, where there is lack of data integrity and modeling for using remote IoT sensor for nitrate, phosphorus, soil, biomass, and invertebrates. And if not, let's say, if it might be possible to do it in the future.
The short answer is no and yes. So I think the best thing to do is to take a contact on that, and then we can investigate the details of how we might do that.
Okay, good. So it is ongoing, I'll say, all of this. And then, okay, actually we have another question there instead that was addressed by Anneke. And it was a little bit more, let's say, it was a little bit more oriented to the use cases, because she was actually asking also to provide some requirements on the use cases that also BioDT is building. I have also said that we have also organized a webinar on this specifically, but let's say from a development point of view. So let's say, for example, if I look at John, and then I think that most probably we can also, for example, think of requirements that are needed for the research infrastructures, or for example, Sergei and Tomas instead provide a perspective that is a little bit more technical on modeling, let's say. So if you can expand a little bit on this question and provide your perspective here.
Well, I would agree with you that, I mean, we've obviously the requirements that have led to the development of the 4 groups and the 8 use cases is quite extensive and is covered in other presentations. I think the key thing is we define those use cases based on particular challenges we felt relating to biodiversity, and then to pick up existing capabilities in the community, such as existing models, such as existing data from the research infrastructures, and how we might increase their capabilities by using the HPC facilities within BioDT. But I do think overarching that, we want the concept of the digital twin, i.e. there's this interaction between the physical system and this virtual system, and how interaction with that system can actually improve its capability. So hopefully all of those use cases are determined by our ability to use that BioDT digital twin model to improve our capabilities. But I won't go into detail because I think there's other places where that detail can be seen.
Yeah. Thank you, John. Tomas, Sergei, do you want to enrich John's reply, or do you think that it was already a complete answer?
I think, like, from the technical perspective, the challenge was also that many of the use cases or the models now in the biodiversity are not really prepared for the HPC. Some of them also use, like the languages that are not so HPC-like or friendly, let's say. For example, the net logo, it's not really easy to deploy on some machine that has a lot of cores, and then you need to come up with creative ideas. Okay, how can we help such use cases to either rewrite the code or maybe do something specific that will help us to run such models on the HPC effectively. So these parts are probably part of the technical detail. Also, then how to make this step from the how to get results to the users is one another thing that was part of what we need to solve. And like we already have the ideas, we already know what we want to do, but still it needs to be clear up on these points, I would say.
Sergei, do you want to add something here?
Well, actually, I think the answer is more than complete, so I don't have anything from my side to add.
Okay, perfect. Thank you. Then we also have, let's say, a question from Tony, and he's asking if we have any examples of how digital twin can also influence policymakers on land use and rewilding. What I would say here, Tony, is that we are developing 4 groups of use cases. We can also share with you the link where you can also find more information. And we have in particular some of the use cases that are also related to crops, for example, to land use. So then you can also explore and visit our website to learn a little bit more about this. I see that actually we are almost at the very end of our webinar. Oh, yes, John, please.
Well, I just very quickly to say that the use case that I was talking about was obviously developed in a national park. So we've had existing meetings with the national park managers and the landowners there to say, does this design of what we're doing fit your requirements? So we don't have an example of how it's actually influencing policy now, but we are certainly working with land managers to ensure that the design should do that.
Thank you, John. Actually, so we're at the very end of our webinar, because I see that this hour has really, it really moved very fast. So actually, before really also concluding it, and also, let's say, thanking again all our attendees, I would like really to ask all of you really to also, let's say, very in a minute, also share with all the attendees the key takeaway, let's say, that they can really take from the webinar today. Maybe, I don't know, Tomas can start, then John, and then Sergei.
Okay, so from the architecture and technical point of view, I think the key giveaway is that now we prepare the architecture that is ready to ingest multiple BioDTs and is as easy as possible to add and ingest new DTs, you know, as for developers, and is also provide really nice tools for the end users. So I think this is my takeaway.
Thank you, Thomas. John?
I think it's as Thomas has said, it's a key thing around this interaction loop. So we've got this workflow of, you know, here are these data, ever increasing data, every you know, data from outside as well as within inside our systems. We've got the models. As Sergei said, how do we actually really utilize the resources we've got to do that? So it's really getting, you know, down to work with actually how we implement that and make sure the users are engaged in what we produce.
Thank you, John. Sergei?
Okay, from my side, I would say that the main takeaway is that we have pretty much of different components that we need to integrate between each other, and we are really working on it. So yeah.
Thank you. Thank you, everyone. Really, thanks again for to Thomas, John, and Sergei for joining our webinar today, and also providing an overview of the BioDT prototype, also, say, from a technical point of view. And I would like also to thank again all our attendees. Then please be in contact with BioDT. You can always send us a message at info@biodt.eu in case you would like to address any questions about the technical development of BioDT, or simply cooperate with us. So I wish you all a very pleasant day. Bye-bye.
Thank you.
Thank you. Bye.
Bye.